motorcycle and you sitting on it probably weighs in the area of 800 pounds. Yeah? How much of that's on the front wheel?
60%.
Huh?
60%.
60% is on the front wheel? No.
Oh, you mean a braking or you just weight?
Wait.
It should be 50, right? 50.
No, it's not that 50. About 300 pounds of that 800 is on the front wheel, and about 500 is on the rear wheel, unless, of course, you're carrying a passenger. Right? And if you're carrying a passenger, how much weight do you add to the front tire? How much? Zero. Because every one of you bikers have a pillion that's directly on top of your rear wheel axle. Well, let me give you another, right off the wall example. You buy a BMW in Houston, and you drive it to Mexico City. Can you stop it as fast in Mexico City as you can in Houston?
No, because you have less traction over there.
Does you have what?
Less traction.
Less traction.
The roads are not as thick as
Well, let's say they were identical. The roads were identical. Sir.
The force of gravity is less in Mexico City than it is here.
Yes, sir. That is absolutely brilliant. You're the first person I have talked to in years that's known that. Your motorcycle weighs less in Mexico City than it does in Houston. The closer you get to the equator, the more centrifugal force you have trying to throw that motorcycle in the sky. Right? Furthermore, the poles of the Earth are closer to the center of the Earth than as you get toward the equator. The farther away from the center you are, the less gravity there is. Now, people, what a silly thing for us to be talking about. Except, we started this conversation, you all told me, adding weight increases the amount of time it takes to stop a motorcycle. So, losing weight ought to make it stop quicker, right? No. Because it's not your brakes. It is not your brakes that determine how quickly you can stop your bike or what the distance is it takes to stop your bike. It's traction. If you squeeze on your front brake, you can lock the front wheel at virtually any speed. Same with the rear brake. It takes more braking energy to lock the brake than it does to get close to that lock, right? The traction on the rubber on your bikes on asphalt is such that you would take 1.1 G of force before it breaks away. 32 feet per second is 1 G. That's how fast you accelerate to the earth when you fall. So if you were to apply your brakes such that you scrubbed speed at 32 feet per second, you'd be scrubbing at 1 G. Very close to skidding. Well, when your rubber skids, you lose 20% of your traction just like that. I guess I'll throw another one. I'll lob another one on the table for you guys. The faster you go, the lighter you get. Do you believe me or not? Trust me. Honest. There are two centers on a bike that should be important to you. Center of gravity. That's important because when you accelerate or you decelerate, it's the lever. It determines how much weight transfers. The higher your center of gravity compared to your wheelbase, the greater the weight transfer is when you accelerate or decelerate. There's a second kind of center that's really important. It's the center of wind resistance. Something none of you have thought about. Any of you have windscreens on your bike? Yeah? Any of them point forward instead of point back? No. Well, if they pointed forward, you'd probably lose weight on the front end. Probably work like a scoop, right? So because they point back, the faster you go, you think the front end gets heavier or lighter? Wrong!
Oh, yeah.
Because you have a center of wind resistance, which is usually rather substantially above your navel, and the center of gravity of your contraption in yourself is below that. Any wind that goes higher than that tries to push weight from the front to the back, and any wind that hits lower tries to rotate you toward the front, because all your forward motion energy is coming from your contact patches, right? So everything trying to slow it down is higher than that, right? So there's torque trying to add weight to the rear. And you're going to do that by taking it off the front. And so the bigger your windscreen, the lighter your front end is going to get with speed.
Okay.
Which, you know, you kind of think, well, okay, so there's a trade-off. I have more weight on the back. Well, when you ride behind a windscreen, have any of you noticed that your jacket will kind of puff up and you get a little pillow behind your neck? Well, that's because the wind that goes over your windscreen goes turbulent behind you. And that's low pressure. Lower pressure than the air below your motorcycle, for example. And because it's low pressure, it's trying to lift your jacket, for example. And it's doing the same thing to your motorcycle. Now, you don't have a wing. You don't have an airfoil on your motorcycle. But I'm going to tell you a fact. That turbulence is significant. If your bike weighed 800 pounds, sitting in your garage, at 75 miles an hour, it will weigh approximately 750 pounds. 50 pounds loss of weight, total weight. How does that happen? I told you, the turbulence is low pressure. Now, ladies and gentlemen, we started with a motorcycle that had 300 pounds in the front and 500 pounds in the back. Then we got up to 75 miles an hour, and that pushed 100 pounds off the front tire and put it on the back. So now you got a motorcycle that got 200 pounds in the front and 600 pounds in the back. Except the bike doesn't weigh 800 pounds anymore. It's no longer 200 pounds in the front, it's 180. And it's no longer 600 in the back, it's 570. The total is 750. Now, numbers. Who needs it, right? Well, it depends. If you like to snap your bike into a turn, you probably don't want the bike to wash out on you when you do that. Say it differently. You don't want so much weight to go off the front end that you're effectively driving a unicycle, right? Because the limit of how fast you can go, I don't care how big an engine you have or how well geared it is the speed at which you can no longer control the motorcycle. Which means the speed with which you no longer have any weight on the front tire, so you can't steer. Have you thought of that before? Do any of you pull a trailer? How much tongue weight do you have on your trailer?
I don't really know.
Well, it's too bad, because you can die not knowing. All right. Well, we talked a lot about brakes, talked a lot about traction, talked a lot about things like trailers. We don't know what the tongue weight is, and I want to know why that's so important. Well, if you have weight transfer on the bike, when you brake or accelerate, you have it on a trailer as well. It is not true that a trailer just pushes on the tongue on your bike. There's a weight transfer for each trailer, so you better not only try to put the weight of everything you put in that trailer over the wheels with just a little bit on the front, but you want to put the heaviest of it on the bottom. get the lowest center of gravity, so that you have a minimal lever in terms of weight transfer. Now, why? Because when you brake and you're pulling a trailer, the tongue pushes your rear end down behind the axle of your rear wheel, which lifts your front end, which was only 170 pounds at 75 miles an hour. And the tongue weight could easily be 100 pounds, especially when you hit your brakes. Do I need to say anything?